Hello, so today we're looking at rules of differentiation. Whoops. All right, so it's going to take me a while to get used to this new Miro board. I like them, but a lot of features. It's impressive, hard to keep track. Okay, so we're asked to differentiate the following. So we're given the function, let's pick a color. So we're given the function f of x equals 7x cubed plus 2x all raised to the power 3. So we need to use some of these rules of differentiation. So what rules are we going to be using here? So we're going to use the power rule. So the power rule, maybe you can just write it out here. If f of x equals like x to the n, then f prime of x equals n times x raised to the power n minus 1, where n is a number, a real number. So let's use this rule and see what happens. So f prime equals, so 3 is our n, so bring it down, 3 times 7x cubed plus 2x all raised to the power 2. So 3 minus 1 is 2. Times, now we need to use the chain rule and differentiate what's within the bracket. So what do we have here? We have 21x squared plus 2. So this is our derivative. So we used a few rules. We used this power rule, we used a chain rule, and then when taking the derivative of what's in the round brackets, we use like the addition rule. So what is the addition rule? The addition rule is if our function h looks like, let's say, gx plus, let's say, lx, then h prime of x is g prime of x plus l prime of x. And the same thing, and correspondingly or equivalently, if we had g minus l, we get g prime minus l prime. Okay, and does everyone remember the chain rule? Okay, let's write it out. So capital F of x equals, what letter should we use? G of h of x. Then f prime equals g prime evaluated at h of x times h prime of x. So this is the chain rule. These are your addition, subtraction rules. And above we had that power rule. Let's put that in. Power rule. Again, all the rules, well, not all, but most of the rules, these are some of the rules of differentiation. Okay, so let's look at the next one. So y equals negative 3x squared plus 4 times 5x cubed plus 2 all raised to the power 2. Okay, so here we need, again, to use a combination of rules. We need to use the product rule because they have two functions multiplied together. One of the functions has a power, so we're going to use the power rule, and of course the chain rule. Because for the power rule, for this function, we have something within the brackets. All right, so let's get started. We're going to start with the product rule. Let's take the derivative of the first function, negative 6x, good, and then times the second function, 5x cubed plus 2 all squared, plus first function, negative 3x squared plus 4, times the derivative of the second function. So 2 times 5x cubed plus 2. All right, well, actually, why don't we make this a little smaller so hopefully I can fit everything in, times the derivative of what's in the bracket. Whoops. Oh dear, what was that? Okay. Times what's in the bracket, which is 15x squared. So that's the derivative of our function y. Now we can simplify it, but it's not really necessary. Again, I always tell students the more work you do, the more chance of error you're going to get. So do what you have to do. All right, so next question. F of x equals 2x cubed minus x over 6x plus 2. So now we have a quotient. So we're going to use the quotient rule. So what is the quotient rule? So f of x equals g of x over h of x. The quotient rule tells us that f prime of x equals g prime of x times h of x minus g of x times h prime of x all over h of x all squared. All right, so let's do this. Okay, so f prime is a derivative of the numerator 6x squared minus 1 times the denominator 6x plus x squared minus the numerator 2x cubed minus x times the denominator 6 plus 2x all over 6x plus x squared all squared. So this is our answer. This is our derivative. You may be asked to simplify, so why don't we give this a try? 36x cubed plus 6x to the power 4 minus 6x minus x squared minus 12x cubed plus 4x to the power 4 minus 6x minus 2x squared all over 6x plus x squared all squared. Let's see if we can simplify this numerator. So 36x cubed minus 12x cubed, what's that, 24x cubed? And what do we have? We have 6x to the power 4 minus 4x to the power 4, so that's plus 2x to the power 4. And we have negative 6x minus negative 6x of 0x, sorry. Then we have negative x squared minus negative 2x squared. That gives us x squared, and that's all over 6x minus x squared all squared. Okay, so we can simplify this a little bit more. Okay, so in the numerator, we can cancel it. We can factor out x squared, giving us 24x plus 2x squared plus 1. In the numerator, we can also factor out an x squared. And then we're left with 6 minus x all squared. The x squareds cancel out. I'm trying to think if we can factor this. No, we cannot. And we're left with, let's move over to the right. 2x squared plus 24x plus 1 over 6 minus x all squared. And this is provided x does not equal 0, of course. Good. Okay, let's see, what do we have next? All right, so here y equals, in brackets, x to the power 5 times the square root of x squared minus 1 over 3x plus x squared minus 2 all squared. Okay, so again, all kinds of rules we're going to use here. Power rule, chain rule, quotient rule, product rule. So let's get started. So y prime equals 2 times x to the power 5. I'm just going to write out, just copy everything out that's in the brackets. Raised to the power 1 times, now we're going to take the derivative of what is in the brackets. Let's put big square brackets and work with that. Okay, so derivative of the numerator. So 5x to the power 4 times x squared minus 1 plus x to the power 5 times 1/2 times x squared minus 1 raised to the power negative 1/2 times 2x. So that's the derivative of the numerator. Okay, times our denominator. So I put round brackets around it, 3x plus x squared minus 1. Okay, minus, all right. So these questions can be very, very long. We're going to need some space. All right, minus the derivative of the denominator, 3 plus 2x times the numerator, 5x to the power 5 times the square root of x squared minus 1. You can close square brackets all over 3x plus x squared minus 1 all squared. Okay, so that is our derivative. Doesn't look good. So we can simplify, or we can just leave it like this. It's a bit of a mess. Trying to look for the easiest way to simplify this. You know what? Let's leave it at that. We've made no mistakes. So what rules did we use? We used the power rule. And then use the quotient rule, product rule, take the derivative of that numerator. And then for each term or each function within the product, the numerator and denominator, we have to use addition and or subtraction rules. And of course, the chain rule. So I think we used all the rules for this one. All right, great. That brings us to the end of our session. If you have any questions, send us a note by email at info@raisedbymarks.com or by phone, day or evening, and we'll be happy to answer your questions. Thank you for watching. See you soon.